Thank you. At this time, we're going to open it up for questions from the judges, and they'll have 10 minutes to discuss the previous written section and/or the presentation today. So you can go ahead.
Good morning. Thank you for your presentation. I have a question. You wrote here Cuba is able to use the hydrologic network to obtain water level data and safely evacuate cities and towns before major flooding occurs. My question is, how is your tool actually, whether it's working together with the manual gathered data, or is it separate, completely independent? And I understand it's a stochastic model, and model has some predictability based on some assumptions, while this is real data. So how will an engineer actually, or a scientist actually evaluate the real data versus the model that you provide?
That is an excellent question. With this model, the idea is to supplement the data available. Using the measured data along with these models can help you have a better picture. The idea with this model is that, especially in areas where there's not that ability to take that data, they can get a better idea of what's going to happen. Also, the predictability of being able to see 15 days into the future can give an idea of where there could be a flood, and then if you want to, you can go take more measurements to be sure.
Just to add on to that, if there is no historic data available, it could be very difficult for an engineer to know how to predict if the flows they're going to see are going to be above normal, or they're going to cause damage. So by accessing this data that comes from tested European models and statistical meteorology, they have the context to make predictions, and then they could use statistical distributions like the Gumbel method or other common practices to predict the future.
Additionally, BYU has also developed some statistical tools for comparing the forecast to observed data to help the people using it in that specific area to get a better understanding of how the forecast performs compared to their measured data.
So, great presentation. I happened to graduate from a university in Cuba, and I worked at the hydraulics department, so I can testify about how difficult it is to gather data, but it's happening. So my question is, if, as my colleague mentioned, you are based on forecasting, but how do you actually check that your forecast actually happened later? So how do you validate real data? So my question is, do you reach out to the institute that gathered this information in Cuba? Do you went further to actually confirm that this is happening? And then, as he asked, how do you match what they are doing and what you are proposing, taking in consideration that, I don't know if you know, but access to internet in Cuba is not that easy. So you are proposing a solution that is based mostly on internet, but how do you connect something that is really difficult to access to something that they're already doing? And if you go further to actually find a good solution or recommendation for the way that Cuba operates.
You want to take it?
Yeah, sure. Yeah, no, that's a great question. Of course, anytime you're predicting something, you need to know how good your estimation is. That depends on your assumptions and everything. So the streamflow prediction tool can be somewhat tailored to specific areas. Cuba being an island, obviously is going to have different needs than the United States, which is a large continuous land mass. So having the measured data that, as you mentioned, is beginning to be collected around the country, you can compare the measured values with the predicted values, and then since the tool has left research and moved to the European Center for Medium Range Weather Forecasting, it can be tailored there and get better results over time for Cuba in general.
You reach out to the department that does that in Cuba?
We have not yet.
We weren't able to be in contact with them for this project yet.
Do you know who they are, or which department?
No. We tried to get in contact through some of our contacts in the Dominican Republic and weren't able to.
You know, I have a similar question that Armando had, but let me adjust myself to how many countries are now connected to this system? That's my first question. And two, when these countries, they connect to this system, which you said is through the web base, there is any specific expenditure that they need to go? You said it is connecting to the web bases for free, but is any investment within the country where they need to do in order to better provide you with the better results or better data, or how it has been in the past with the other countries that they are connected to?
Okay, so I'll answer your first question. We do a lot of work with the Dominican Republic. Additionally, in Bangladesh and Nepal, we are doing a lot of work with this specific tool. Okay. In terms of costs, to access the forecast, they wouldn't have, all they need is the internet. Now if they, depending on how much they want to understand how the forecast compares to their measured data, you'd have to go collect measured data and compare it. Because they're already collecting data, we could compare data there. It really depends on what they want to do. For example, this flood mapping tool, to apply that to Cuba, we'd have to get some more local elevation data, for example, to get the flood mapping. But that could be done with BYU as a partnership.
Okay, for example, you mentioned the Dominican Republic. It's how it's going, I mean, for how long you've been doing this with the Dominican Republic, and if you know if exactly what the data they are obtaining from them is really accurate, how much do they spend in doing that?
Yeah.
I guess it's very similar to Cuba. It's in the same area. That's all I wonder why.
Yeah, that's a great point. The Dominican Republic is topographically and locations very similar to Cuba. The research lab that we come from has been partnered with INJURI in the Dominican Republic for 10 years now, and every year we make a trip down there and we work with the people there. This is all, the students pay for it themselves as a senior project, so it hasn't cost them much, if anything. They just use their own computers that they already have, and they're looking into the possibility of developing more of their own apps and setting up their own servers, which would be an additional cost depending on exactly how they decided to go about it. But so far it's been just a free partnership for them.
Just following up on the same subject, what kind of investment would be required in terms of intellectual capital, in terms of coding, modifying computer programs from Cuban engineers, if you will? What access do they have to the model so they can tailor it to their specific needs? Is it something, you mentioned that you had partners at NASA, UN, World Bank, et cetera. While you guys contribute your own work, that may be free. I don't know, at NASA, World Bank, UN, anybody else, or UWCF, will be doing work for free. So assuming that Cuba were to adopt the system, if you will, what would they need in terms of intellectual capital and also dollars associated with modifying the program? Is that something that they can do themselves, or does UWMCF, or I can't remember the acronym, that's something that they need to do and it has a cost?
Yeah, so as someone who has less experience than these two with the app, just to use the app, it's very straightforward, and you really don't need much more experience than just a general knowledge of computers. To get in, to actually, with the way the applications are housed, it's fairly simple to go in and create your own derivative applications. You would typically need a basic understanding of computer coding, but no more than a couple classes to be able to effectively start to build your own apps.
Just to follow up, the initial research grant that funded the development of this tool had the express purpose of lowering barriers, these kind of technical barriers that you're getting at between the decision makers and the engineers, and being able to do predictive models and access the tools they need. So there's actually the apps that we showed you in the videos and the screenshots were developed from a platform that came out of that. It's very well documented, and it's already been developed such that people that don't have the coding experience that you're describing have a variety of tools, and it's intended with it was designed for those people in mind.
One quick question, a yes or no question. Based on this tool alone, will you evacuate a city if it predicts there's going to be some flooding? Will you have enough confidence that just based on this tool alone, will you cause 10,000 people to move from there? Yes or
Are
no?
you referring to the flood mapping thing?
To the tools that you're presenting.
I would say yes.
What about you?
I would say that it would be wise to compare to data and see, and then you can figure out if there's bias in the forecast.
Just based on the tool?
Just today.
Yes. Would you use this tool to evacuate and remove 5,000 people out of the city?
I don't think so.
Okay, thank you.
I would agree with Chris, not just with this tool.
Thank you very much, very honest.
We still have a little bit of time left in their question and answer session, if there's any other questions from the audience. Yeah? Hold on a second.
Former professor, but
This is for
I was with Duke University. Is this on?
That's perfectly. It's not going to be audio.
Oh, okay. So anyway, my question is, what are the underlying mechanics in this model? I figure it probably uses some stochastic tools like extreme value distributions, log Pearson, and so forth. But what about the flood mapping? You need to have some mechanics in routing so that you can get the lateral extent. So what are we talking about here? Dynamic waves, kinematic waves? Do you know what the details are?
So for the streamflow forecast, it uses a model called RAPID, which is a river routing model. And for the flood mapping, it's a method known as the hand method, height above nearest drainage method.
Okay, thank you.
One more? Oh, okay.
My question is directed more about the real-world application of the model. I mean, it's a great model, and I commend, your university for kind of enhancing it. All good. Another thing is, or another way to look at it is, so I want to develop a solution to evacuate people in case of a flood, right? And so this is the answer to that question, as opposed to here's a great model, go use it. So the question is, did you give any thought to the real world applications of the model? Maybe this is the same thing that that was asked a minute ago in a different way, but a real world, how do I use this model to answer a question that is real world? Did you give any thought to that?
I would say for real-world application, it would be important to compare the model results to measured data to get an idea of any biases in the model and seeing what kind of results you're getting. And then you'd be able to use the results and understanding what they're giving you relative. You can have a confidence in what the results are giving you. There are various ways to access the results for each stream that can be automated, that a user could automatically see the results of whatever streams they're interested in. They don't have to go into this tool directly. There are ways to do that they could get the results for the river they're interested in every day.
Right, but I think I'm trying to guide you to what question are you trying to solve, other than here's a great piece of technology and here's a model that gives you some really, really good information. That's great, but what question are you trying to answer? What problem are you trying to solve, right? So it could be, I want to evacuate people, right? I want to preserve, my manufacturing plants, right? That's the kind of solution, right? You've talked about the model. We understand the model. It's a great model, right? And by the way, these guys are far ahead of where NOAA is, and et cetera. We all, have great things to say about them. But did you give some thought to the answer or the question that you're trying to answer, as opposed to this is a great model?
So I guess a couple of the questions that we brought about is, what is the extent of the flood going to be? Or we also showed the application for reservoir management. What is the reservoir level going to be? How should I manage this reservoir? How much should I let out? Things like that.
And additionally, that's what we would hope to be able to better address in a partnership between Cuba and the international community, is we've developed these global models that provide you the foundation that you need to answer specific questions. But a global model can't, global models can't answer every question everywhere. There's no model's perfect. So we would address specific needs as in the application phase.
When you mentioned that you had an annual historical data, is that available for Cuba, or is that only available for certain parts of the world?
So the historical data we showed is available everywhere. It is a simulation based on the European model's retrospective meteorology.
So it's historical simulations.
So
Well, we would have forecasted for, if
It's-
we have forecasted for a year, we go and take a look back, and this is what my forecast was for the last year. But it's not actual data.
The historical data we're showing is more of, they use all the global records they have of meteorology and then produce kind of the same forecast, but in the past. So this can be valuable in areas where there's not measured data, and where you do have measured data, you can compare to see.
And do they do it globally, or do they do it by watersheds? Or
It's
what?
globally.
Globally, okay, thank you.
Well, thank you so much. Let's go ahead and give Chris and his team a great round of applause. Thank you.